Good morning, students. We have started our chapter electricity and we have done the properties of charge. Today, let us start the electric potential and potential difference, which is the very important part to flow the current. Students, very simply, we are knowing that if we take two tanks, suppose one is at this height and another is at this height, and join the pipe from these two, fill water in it. Naturally, you will find that water is flowing from tank A to tank B. Nothing we have to do because the tank A is at upper distance and it has more water is having more potential energy comparison to the tank B. But student, what happens if both the tanks are at the same level? Both the tanks are at the same level. Suppose tank A consists of water at this level and tank B consists of water at very lower level. Suppose only at this level. Join both the tank See this? Join both the tank. In between, suppose you are having a tap. Open the tap. Then you will find that the water from the tank A flows to tank B. Why this is happening? Because in tank A, water level is higher. And so it flows to tank B and it goes on flowing till when both the tank is having the same level of water. Both the tank reaches at the same level, then it stops. So what you have got conclusion from this? That if it is at higher potential, if it is at higher strength, then the water will flow from one place to another place. Same thing is happening in electricity also. Let us see what is this. Potential means strength. Suppose at this field, it is electric field and we have brought one unit positive charge at this field. Then as we have brought this unit positive charge at this field, naturally it will feel some force and it will feel the force of repulsion. Then what we have to do to bring this charge, to keep this charge in this field only? So for that purpose, we have to do some work. So same thing, electric potential at a point in an electric field is the amount of work done in moving unit positive charge from infinity to that point. If you have to bring this positive charge at point B and this point positive charge is at point A. So naturally we have to do some work to bring this unit positive charge at point B in an electric field. This is known as electric potential. So again once I am saying you the definition. Electric potential at a point in an electric field is the amount of work done. See, to bring from charge from point A to B, we have to do some work. So work done in moving unit positive charge from infinity to certain fixed point. Related to this only, we have got one more term, that is potential difference. Then what is difference? In tank 1 we have seen, if there is a difference in water, then only the water flows from one tank to another one. If there is no differences, it does not flow. Same way, electric current also, if there is difference in their potential, the current flow. So first of all, let us see what is this potential difference. Potential difference is the amount of work done to move unit positive charge from one point to another point or across the end of the conductor. Potential difference is denoted by V. So, what you have got? Work done, W. What we are doing? We are bringing unit positive charge from infinity to certain fixed point or from one point to another point. That means Q. So, we are having a formula for potential difference. V is equal to W by Q. The SI unit of W is, that is work done, is joule, and SI unit of Q is coulomb, that is charge is coulomb, and SI unit of this potential difference is, by the name of scientist only, voltage, that is volt. So I think student, you will not get confused here. Here potential difference is also shown by V, and SI unit you can also show it by V, or you can write it as volt. So this is the potential difference. Difference in strength, so that charge flows from one point to another point. So students, again we think that, then where the charge flows? For that we need circuit, that is electric circuit. What is electric circuit? The closed and continuous path through which charge can flow is known as electric circuit. For example, simply I am showing you, suppose we are connecting the bulb with wire and we have taken simply one cell. So whenever you will connect the cell with this bulb, the bulb starts glowing. Why this bulb starts glowing? Because the current started flowing. It shows the glowing of the bulb shows the current flows in the circuit. So you see here, in whole of the circuit, it is continuous, no break is there. So whenever there is a closed and continuous path, the charge will get, then only charge flows. But student, remember, there are two essential conditions, then only current flows. What are the two essential conditions? First is, just now you have studied closed and continuous path. Closed and continuous path. Then only the current will flow. So you need circuit. And second is, there must be potential difference. Potential difference. If there will be no difference in charge, then who will flow? No one will flow, but it will become stable. So there must be potential difference, and then only the current will flow.